Hello, this is Otutochi Caleb Wadimba from Special Maths Academy, and in this video, we'll be solving the problem 4 of the recently concluded 2023 NMC third round. So here we are told a number is called prime looking if it is composite, but if it's composite but not divisible by 2, 3, or 5, and they give us examples of 49, 77, and 91. And of course, we are given an information for free. There are 305 prime numbers less than 2023, and then asked to find the number of prime looking numbers less than 2023. So from the definition, a number is prime looking if it is composite but not divisible by 2, 3, and 5. Of course, all numbers divisible by 2, 3, and 5 are composites. So if you can find the total number of composite numbers less than 2023, and then subtract the number of composite numbers that are divisible by either 2, 3, or 5, then we'll be done with this problem. Now this can be done because we can easily find the number of integers, the number of positive integers less than the number that are divisible by it using this formula nk, right? So we know that the number of integers less than or equal to n, less than or equal to n that are divisible by k can be gotten by floor function of n over k, right? For example, the number of positive integers less than or equal to 12 that are divisible by 6 will be floor function of 12 over 6, which will give us 2. Of course, we can check that those two numbers are 6 and 12. Right? For example, the number of positive integers that are less than 10 but divisible by 3, we can get that with 10 over 3, right? And then that will give us 3. And you can check that those numbers are 3, 6, 9, blah, blah, blah. So now this formula, right, is the number of positive integers less than n, but less than n and less than or equal to n and divisible by k, right? So now you are dealing with 2, 3, and 5 here. And of course, we are looking at less than 2023. So if a positive integer is less than 2023, then it has to be less than or equal to 2022. So we're working with 2022. It doesn't really matter because 2023 is neither divisible by 2, 3, or 5. But for a different number, it would have made a difference of 1 or 2. Right? So basically, let's say, we are dealing with less than or equal to 2022, right? And of course, we are checking if it's divisible by 2, 3, or 5. Right? So just do plot function of 2022 over 2 is going to give us 1011, of course. Plot function of 2022 over 3 is going to give us 674. Plot function of 2022 over 5 is going to give us 404. Right, but then of course it's not just a simple matter of adding these 3, because some numbers will be divisible by both 2 and 3. Some are divisible by both 2 and 5. Some are divisible by both 2 and 5. Some are even divisible by all 3, as in the case of 30. So also check for those numbers. So those that be divisible by both 2 and 3 are divisible by 6. So 2022 over 6. Right, to give us 337. Right, then of course we'll do 2022 over both 2 and 5. So that will give us 2 times 5, 10. To give us 222, 2.2. So that will give us 202 when you take the floor function of that. And the next will be 2022 over 3 times 5. And then that would be 134. And of course, the number that is divisible by all 3 is going to be 2022 over 6. 2022 over 30, right? 10 times 2, so that gives us 67. Now, if you want to check the number, so this is the number that is divisible by 2, the one that is divisible by 3, the one that is divisible by 5. So if you're adding them, you are going to count these ones twice, right? So how we are going to do this? So this is just the general formula from sets. I'll just put that here. So this will be 2022 over 2 plus 2022 over 3 plus 2022 over 5, right? And of course, when you add, for example, when you're adding 2 and 3, you are counting number that are divisible by both 2 and 3 twice, but you just need one of those. So of course, you have to be subtracting. You have to subtract when they come in pairs. So that would be 2022 over 6 minus 2022 over 10. Floor function, of course, the floor function, yeah, floor functions minus floor function of 2022 over 15. And then when we subtract all this, we will subtract the ones that are divisible by 3 of them. For example, the one that is divisible by 3 of them will appear here, and appear here. So in this, we have counted it 3 times, right? And then as you are subtracting, it will also appear here and here. So we'll subtract it 3 times again. So we just have to add it back, right? 2022 over 30. And this is going to give us our answer. So our answer is going to look like this, right? So of course, when we do that, this will be 1011 plus 674 plus 404 minus 337 minus 202 minus 134. Then we'll add that 67 back, right? And when we perform this operation, we should get 1483. Now, this is not an answer. These are the number of composite numbers that are divisible by 2, 3, or 5. I remember we had to subtract this from the total number of composite numbers. So how do you get the number of composite numbers? So, right, we are given an information for 3 that 305, there are 305 prime numbers less than 2023. So all we need to do is we know that there are 2022 numbers less than 2023. 305 of them are prime, right? And of course, there's 1. So one of them is neither prime nor composite. So we know that at least 306 of them are not composite. So we just subtract the number of integers that less than 2023 that are not composite, which is 306, from the total number of positive integers less than 2023, which is 2022. So we'll be doing 2022 minus 306, right? And that's going to give us 1716, right? So then our answer is going to be 1483, or rather 1716. Our answer now is going to be 1716, which is the total number of composite numbers. So this is the number of composites, right? And these are the composite numbers that are divisible by 2, 2, or 3, right? So subtract the total number of composite numbers, right? So subtract the number that are divisible by 2, 3, or 5 from the total number of composite numbers. So this will be 1716 minus 1483. And that's going to give us 233. And of course, that would be the number of prime looking, right? So this will give us the number of prime looking numbers. So yeah, so there are 233 prime looking numbers that are less than 2023, and that concludes this problem. Stay tuned for the next.